start to study of chapter 2. As you know that in a prior lectures, we have finished chapter 1 by 3 lectures, which they are quick review. And for today, we're going to talk about chapter 2. Chapter 2, it's very easy. It consists of 2 sections, which are section 1 is about compounds in their aqueous solution, and section 2 is about colligative properties. For section 1, compounds and aqueous solutions, it means for whole of section 1, when we talk about any solution, water is a solvent. H2O is a solvent. H2O is a solvent. Okay? So when we say aqueous solution, H2O is a solvent. We learned that in chapter 1. Before starting this chapter, hopefully you remember how to write a formula for chemicals, as you learned in grade 11, chapter 1, section 1 in your first season. Okay, but we will talk about the ions quickly. Group 1 elements, group 1 metals always produce +1 ions in their compounds. Group 1, which are lithium, sodium, potassium, rubidium, cesium, and francium also. But we didn't mention francium because of it only persists in trace amount, and we don't have applications of them, of francium still now. About group 2 metals always produces +2 ions in the compounds such as beryllium, magnesium, calcium, strontium, and barium. Halogens always produce -1 ions because of due to their strongest electronegativity in the periodic table, so they always producing a -1 ions because of they need only 1 electron to filling their outermost shell electron. When we do the electron configuration for the halogens, we can see that thing very easily. Cadmium is +2, silver +1, aluminum +3, nickel +2, zinc +3, and nitride is equal. Nitride is N -3. This is nitride and -3. Sulfide is -2. For Stokes system elements, you don't have to be worried because of the charge of the Stokes system elements will be identified by a question itself. And also we have some polyatomic ions. This is very important. You will need that in chapter 3, chapter 4, chapter 7, even chapter 8. It's very important. And we can get the polyatomic ions mostly by ionizing the acids, whereby after losing a proton, you will learn that in chapter 3 and chapter 4. Ammonium is the only polyatomic ions which has +2, which has plus charged, which is NH4 +1. And now let's see how to write a chemical formula. I'll show you some examples just to remind you how to write a chemical formula. For example, barium nitrate. Write a chemical formula for barium nitrate. Barium is Ba+2, nitrate is NO3 -1, so it will be BaNO3 by 2. This is barium nitrate. Another example, cadmium phosphate. Okay, cadmium is Cd+2, phosphate is PO4 -3. Crisscross method, we can get CD3PO4 by 2. Well, in here we use it 2 parentheses, but in here we didn't use it. Because of this is polyatomic ions, so when we have a subscript bigger than 1, we should put them into 2 parentheses. Okay. Now let's make a classification of molecular compounds. We have 2 types of molecular compounds: polar molecular compounds and non-polar molecular compounds. Actually, we will talk about that a little bit more than the others because of it will need us to solve many other things. Very good. non-polar molecular compound and polar molecular compound. Look, non-polar, did you remember when we, at what place we have talked about the polarity, the rule of like dissolves like? You know, when we talk about the rule of like dissolves like, we means polarity. So a non-polar compound is, if you remember, such as carbon tetrachloride, benzene, toluene, and the other compounds. And you can see the non-polar compounds in the list from chapter 1. About a polar molecular compounds, for polar molecular compounds, there are further classification. Let's see. Polar molecular compounds, we have two types of polar molecular compounds. Polar electrolyte and polar non-electrolyte. For polar non-electrolyte, they are not ionized, but for polar electrolyte, they are ionized. Did you remember about electrolyte and non-electrolyte? In electrolyte solution, we have a free charged mobile ion, but in non-electrolyte, we did not have any ion. That's why for non-electrolyte, they can dissolve in water, no problem. Polar non-electrolyte, they can dissolve in water, but they do not produce any ion. But for polar electrolyte, they are dissolved in water and they can produce ion also. Polar non-electrolytes such as sugar and alcohol, okay, they can produce solution at the molecule level. But for polar electrolyte such as strong acid, weak base, even salts are electrolyte, but they are not molecular. That's why we did not mention salt and strong base, because of their ionic compound. We just talk about molecular compound. They are ionized in water. They can produce a solution that can conduct electricity, and that solution will be at the ionic level. Okay, we talked about strong acid, weak base. That's why we should memorize list of weak acids, weak base, strong acids, strong bases. For strong acids, it's very important, one of the most important tables in this book. Strong acids such as HCl, HBr, HI, H2SO4, HCrO4. Actually, this is out of our book. We can forget about chromic acid, chloric acid, and perchloric acid, nitric acid, and so on. There are many other strong acids. For weak acid, HF, hydrofluoric acid, HCl, this is semi-binary acid, but this is weak acid, H2S, HCOH, H2SO3, H3PO3, H3PO4, and so on. Weak base such as ammonia, it's very important, ammonia, aniline and methylamine also. Strong bases, group 1 element, sodium, rubidium, lithium, potassium, cesium. They are group 1 elements, so when they combine with one OH, they can produce strong base. And barium, calcium, strontium, in a group 2 metals, they can produce strong base also. BiOH by 2, CaOH by 2, SrOH by 2. That's why please memorize this table. Okay. Good. Now, a molecular compound that can ionize. Well, a molecular compound that can ionize. Look, molecular compound. Okay, very easy. That can ionize. It means electrolyte. Molecular. Look, molecular electrolyte. Molecular electrolyte. Acid. Strong acid, weak acid, and weak base. Look, this is sucrose, it's sugar, no. This is alcohol, no. NaCl, right, this is electrolyte, but it's not molecular, this is ionic. So the right answer is HF. HF is weak acid. That's why a molecular compound that can ionize should be strong acid or weak base. There are two basic types of compounds, so it depends on the type of bonding in the compounds. There are two types of the compounds. molecular compound or covalent compound and ionic compound. In molecular compound, we have a covalent bond, but in ionic compound, we have the ionic bond. So the ionic bond is much more stronger than a covalent bond. So there are two types of a compound, this molecular compound and ionic compound. Salt, we have salt also. Salt is an ionic compound, consists of cation and anion. The anion came from the acid mostly. Okay. Dissociation is special phenomena for the ionic compounds. Ionic compounds such as, look, ionic compounds such as strong base and salt. Strong bases and salts are ionic compound. But what about weak base? Weak base is a molecular electrolyte compound. Acids, strong and weak, are molecular compound. Okay. Dissociation reaction is the separation of the ions that occur when the ionic compound dissolves in water. Look, ionic compound in the water will be dissolved, and then it will be break apart to produce its individual ions. For example, barium nitrate is a salt. Salt, we know, salts are ionic compounds. So what will happen if we put ionic compound in the water? They're going to dissociate. BaNO3, we have Ba and NO3. Okay? Ba and NO3. Then balance the equation. We have 2NO3, so we should get 2NO3. I prefer to open a whiteboard than solve that kind of things. And here, okay, it's very good. BaNO3 by 2. When we put BaNO3 into water, we should write water in here. I'll tell you why we should write water in here. To produce Ba plus NO3 -1. They are aqueous. This is solid. And then balance the equation. 1Ba, 2NO3, 2NO3. So for 1 mole of Ba, we get 1 mole BaNO3, we get 1 mole of Ba plus 2 and 2 moles of NO3. The total number of the ions are 3. 3 moles of the ions. So what will happen if we dissolve 2 moles of BaNO3? We should multiply this by 2. This is by 2. So in the result, we will get 6 moles of the ions. What will happen if we dissolve 3 moles of BaNO3? We will get 9 moles of the ions. You see that? It's very easy. Another question. Sodium phosphate. For sodium phosphate, I will write in here. Sodium phosphate. Sodium phosphate, did you remember? I told you how to write a chemical formula. For sodium phosphate, we have Na3PO4. We should dissolve it in water. Water must be right in here to producing sodium plus 1 plus phosphate PO4, sorry, -3. And then balance the equation. We have 3 sodium atoms, so we should write 3 in here. For 1 mole sodium phosphate, we get 3 mole in here and 1 mole in here. The overall will be 4. 3 plus 1. What will happen if we increase by 2 mole? So we should get 8 moles. What will happen if we dissolve 3 moles of sodium phosphate, multiply 4 by 3? It will be 12 moles. That's the dissociation reaction and calculating the mole of the ions. I have another question. Okay. Write the equation for the dissolution of aluminum sulfate. Oh, aluminum sulfate. We have aluminum sulfate. This is aluminum sulfate. Al, and this is phosphate. Al is plus 3. Aluminum sulfate. SO4 negative 2. This is aluminum sulfate. So let's write a compound. Al2 SO4 by 3. So in that kind of question, write the dissociation reaction for aluminum sulfate in water, and then how many moles of aluminum and sulfate can be produced in 1 mole of aluminum sulfate. What are the total numbers of the ions that can be produced by dissolving 1 mole of aluminum sulfate? In that kind of question, immediately point at your compound. What is our compound? Aluminum sulfate. Very good. Then, okay, we pointed at our compound. Then, write the dissociation reaction for 1 mole. Okay, this is dissociation reaction for 1 mole. Aluminum sulfate, we get Al plus SO3. But because we have 2 Al, so we should multiply by 2. We have 3 SO4, we should multiply by 3. Then immediately calculate the number of moles of each individual ions. We have 2 moles of Al, we have 3 moles of sulfate. Then the total number is equal to 5. This is for 1 mole. It's common step for all of the questions. Next, how many number of moles of ions can be produced in dissolving 1 mole of aluminum sulfate? Okay, in 1 mole we get 5 moles. What will happen if a question say 2 mole of aluminum sulfate? So we should multiply 5 by 2. 3 mole, we should multiply 5 by 3. Okay? The last question about that, it's very good. Write the equation for the dissociation of 0.45 mole of barium nitrate, and then determine the number of moles of each of the ions produced, as well as the total number of moles of the ions that can be produced by dissolving this compound. What I told you, point at your compound. This is our compound, barium nitrate. Then immediately write the dissociation reaction for 1 mole. This is barium nitrate, and this is dissociation reaction for 1 mole. We have 2NO3, 2NO3. Then calculate the number of mole of the ions for 1 mole. Don't forget. For 1 mole, we have 2 mole NO3, 1 mole of Ba. So 2 plus 1 is equal to 3. Okay, teacher. Now, I followed your advice. I pointed at my compound, and then I write the dissociation for 1 mole, and then calculated the number of mole of the ions for 1 mole. What's the next step? The question said, find the number of mole for 0.5 mole of barium nitrate. Oh, so we should multiply our result by 0.5. 3 times 0.5 is equal to 3 times 0.5 is equal to 1.5 moles of the ions. You see, it's very easy. So the first step, you should write the dissociation reaction for 1 mole. The first step, you should write the dissociation reaction for 1 mole, then multiply the result of the total number of the ions by the moles that asked by the question. Which of the following can dissociate in water? Oh, can dissociate in water. So we should have salt or strong base. Because of dissociation, this is for ionic compound, salt and strong base. But if it said ionize, this is for strong, weak acid and weak base. Okay, this is strong base. This is salt, this is strong base. So all of them are correct answer. Let's do for that equation, for that question also. Well, this I like that kind of question. For 0.75 liter of a solution of 2 molar ammonium sulfide, NH4/2S, calculate the number of moles of the ions of sulfide and ammonium in that aqueous solution. Or again, it asks you to calculating the number of mole of the ions. So what we have to do, we have to do the steps that I told you. Point at your compound. What is our compound? Ammonium sulfide. So what we have to do, write the dissociation reaction for 1 mole. This is dissociation reaction for 1 mole. Then find the number of mole of the ions per 1 mole. This is 1 mole, this is 2 mole, and the total number of moles is equal to 0.4. This is for 1 mole. But we should ask it by the question, how many moles per this number of mole of the compound? We don't have number of moles, but we have volume and molarity. So we should find out the number of moles. We know that molarity is equal to mole per liter. So mole is equal to molarity times 2 liter. Mole is equal to 0.5. Oh, now we have to multiply our result by 1.5. Okay? We have to multiply our result by 1.5. For 1 mole of NH4/2S, excuse me, we just get 3 moles of the ions. But for 1.5 mole, we get 4.5 mole. Okay, because we multiplied our result by this number of mole. So these are the same. Okay. Now we have rules for the solubility. General rules for the solubility. We have some compounds, you should recognize them, that they can dissolve in water or not. Rule of solubility. S uses for insoluble water compound, and aqueous uses for water-soluble compounds. Water-soluble compounds. Well, the rule says that any compound that consists of sodium, potassium, ammonium, they are soluble in water. They can dissolve in water. Any compound contains nitrate, acetate, and chlorate, perchlorate, they can dissolve in water. You have to memorize them. Most of these chloride compounds are water-soluble, but there's an exception. AgCl, PbCl2 can dissolve in hot water, and mercury chloride also cannot be dissolved in water. So mostly chlorides can dissolve in water except of these 3 compounds. About the sulfate compounds, SO4, mostly sulfate compounds are water soluble except of compounds of sulfate with barium, strontium, Pb, calcium, and silver. Well, I don't want to mention that Kurdish phrase that helps you to memorizing this. You have to find a good way to memorizing these compounds. They are water insoluble compounds. Okay? About sulfides, sulfide mostly are water insoluble, but except of these compounds, they can dissolve in water. Sulfide with calcium, strontium, sodium, potassium, and ammonium. Because any compound that contains potassium, sodium, and ammonium, they will be water soluble. Carbonate compounds, phosphate, silicate, are water insoluble except of those that combine it with sodium, potassium, and ammonium. This is a general rule. They are water soluble. So mostly CO3, PO4, SiO4 negative 2 compounds are water insoluble except of these compounds. Now, let's predict the solubility of the following compounds in the water. KCl contains potassium. It's water soluble. NaNO3 is fully soluble, contains Na and NO3, AgCl insoluble, BaSO4 is insoluble, Ca3PO4 is insoluble, PbClO3 is water soluble, insoluble, and water soluble. So you have to memorize these compounds just like me, that I predict the solubility of them very quickly. Because of we need the following things to solving the questions. Okay, in this question, will a precipitate form when a solution of ammonium sulfide and cadmium nitrate are combined? In that kind of question, first of all, you have to write a compound formula. Okay? Ammonium sulfide is NH4 by 2S. Cadmium nitrate is CdNO3 by 2. So the question says that if we combine these two compounds, or if we mix the aqueous solution of these compounds, will a precipitate form? So first of all, you should write the double displacement reaction. You have to know how to write the double displacement reaction. I recommend to you, please review your informations that you get from grade 11. Don't wait them. You have to make your review before starting grade 11 chemistry, grade 12 chemistry. How to write a chemical formula, how to write the single displacement reaction and double displacement reaction. These are points that helped you to overcome any questions in chapter 2, chapters 3, 7, 4, even 8. It's very important. So let's write the double displacement reaction. NH4 by 2S plus CdNO3 by 2. Because of they are aqueous, so we should write aqueous below the formula of them. This is aqueous. Okay. Aqueous. Now write the double displacement reaction. In the double displacement reaction, Cd with S, NO3 with NH4. So we will get NH4, NO3 plus CdS. That's the double displacement reaction, but still this is not exact molecular reaction. We have to balance the equation, balance the reaction. Okay. We have 2 ammonia in here, but we have 1, so we should multiply it by 2. Now we have 2 nitrates, 1 cadmium, 1 sulfate, 1 sulfate. So the reaction is totally balanced. Then, after writing the double displacement reaction, we should predict the solubility of the products. It's totally soluble, water soluble, but this is the solid. It is the precipitate. So will a precipitate form? Yes. The precipitate is cadmium sulfide. Cadmium sulfide is the precipitate of the reaction between ammonium sulfide and cadmium nitrate. Okay, so this is double displacement reaction. Then write the overall ionic equation. How we can write the overall ionic equation? Okay, we have to dissociate all the aqueous compounds. So we will get 2NH4 plus, okay, plus sulfide negative 2 plus cadmium positive 2 plus 2NO3, and they are aqueous. Due to the weak attraction force between the ions, so they're going to they are dissociate. Now in here we have 2NH4 ions, aqua, plus 2NO3 ions aqua plus. What about that solid? Oh, we cannot separate it into its individual ions because of the strong attraction force between sulfate and cadmium, so it will remain as it is. Solid. Oh. So this is the overall ionic equation. This is the second step. In the second step, after writing a double displacement reaction, we have to split the aqueous compounds, okay, except of the solid, except of the precipitate. Now, what are the spectator ions? The spectator ions are the ions that remain before and after the reaction in the same form. Aqueous, ion. Okay? So the spectator ions, look, NH4 in here is aqueous, NH4 in here is aqueous. So it's spectator ions. This is one spectator. Okay? CD in here, aqueous, is in there, it's solid. No, it's not spectator. This is not spectator also. NO3 negative. In here we have NO3 negative, look. Also in here we get negative NO3. So these are spectator ions. So the spectators are, look, NH4 and NO3. So they are spectator ions. What about the net ionic equation after cancelling the spectator ions? The remain will be net ionic equation, which is S negative 2 plus CD positive 2 to form CDS. CDS. They are aqueous. So that's the net ionic equation. Look how it's easy. The first thing you have to write the double displacement reaction, then split the aqueous compounds, then the ions of the aqueous product will be the spectators. Look, NH4 and O3 are spectators. The ions of the solid product will be the net ionic equation. Okay? That's very easy. Let's solve another question as a last question about that. Will a precipitate form when a solution of ammonium sulfide? Okay. Ammonium sulfide. Ammonium sulfide, this is NH4 by 2S. Okay, I prefer to write it again. NH4 by 2S. This is ammonium sulfide and zinc nitrate. Zinc nitrate, it is ZnNO3 by 2. Okay, the first step, write the double displacement reaction. Okay, NH4 by 2S plus ZnNO3 by 2. So write the double displacement reaction. The double displacement reaction between these compounds is Zn plus S and NH4NO3. Okay. The products are, look, NH4 NO3 plus ZnS. Okay, that's aqueous. It's said by the question. NH4NO3, yeah, it's aqueous. Zn is a solid, so that's the precipitate. Okay, that's the precipitate. About a balancing, now it's balanced. It's very easy. Now, the overall ionic equation, just split the aqueous compounds into individual ions except of the solid. Then write the spectator ion. The spectator ions, we will deal with the aqueous form. NH4 and NO3 are spectator ions. Okay, as I told you, the aqueous salt will be the spectator ions. The ions of the aqueous salt are become the spectator ions. Then the solid become a net ionic equation, ZnS. Okay, so we will have Zn plus 2 plus S negative 2. So that's the net ionic equation. So we're going to build the net ionic equation with the solid salt, which is the precipitate, and we're going to write the spectator ions with the aqueous salt, which is water-soluble salt. So that's about the precipitation reaction and writing the spectator ions and the net ionic equation. Okay. Dear students, now we have the ionization. We've learned about the dissociation. Dissociation, this is for the ionic compounds, strong base and salts. Dissociation. But ionization, this is for weak base, strong acid, strong acid and weak acid. This is for the ionization. Okay? The ionization is the process that ions are formed when the solute molecule by the action of the solvent. Look, when we have a molecular compound and when we dissolve in the water, by the action of the solvent, the ions begin start to form. So I prefer to make the distinguish between the ionization and the dissociation. Ionization and the dissociation. Okay? In here, I'll make a distinguish between the ionization and the dissociation. Right here. Look. Ionization and dissociation. Ionization and dissociation. Look, for ionization, this is applicable for strong acid, weak acid, and weak base. But for the dissociation, it is for strong base and salts. That means they are molecular compound, but they are ionic compound. Okay, so dissociation is for ionic compound, but ionization is for molecular compound. But what molecular compound? They should electrolyte. Okay. Now write the form of the reaction of them. For example, we have HCl. HCl should be plus H2O to form H3O plus negative Cl. But in here, for example, we have NaOH as a strong base. So the water should be right above the arrow to form Na plus hydroxide anion. Okay. Now, can you see the difference between them? Why we write water in here, but why we write water above the arrow? In here, we can see that the ions are present by themselves before and after dissolving the process. Look. We have Na, we have Na, we have OH, and we have OH anion. So do water interferes the formula for the ions? No. Water is just a pool and the ions are swimming in it. Water did not interfere it. Okay? So because of that property of the water, water should be right above the arrow as a just like more or less a catalyst. It's not a catalyst, but think just like that. It's a pool that the ions are swimming in it. But in here, why we write water in here? Because of, we can see that, okay, we have chloride, but do we have H3O before the dissolving process? No. By the action of the solvent, the ion is produced. But in here, without the action of the solvent, ions are produced. Because of we had ions previously. But in here, we did not. Okay, we have H3O inside of HCl? No. When we use water, and water interferes this process, so we get the hydronium ion plus Cl. That's why we're going to say by the action of the solvent. Without the action of the solvent, we cannot get these ions. But in here, no. Without the action of solvent, we have the ions. Water is just a pool to swimming the ions. But in here, no. Okay? So for the ionization reaction, the compound should be plus water. But for the dissociation reaction, water must be right above the arrow. And here the ions are not present before the dissolving process. But in here, the ions are present without the action of the solvent. In here by the action of the solvent, in here without the action of the solvent. So that's the difference between the dissociation and the ionization. Ionization for acid, including strong, weak, and weak base. Molecular electrolyte compounds, but for dissociation for the ionic compound. Okay? So that's all about the ionization and the dissociation reaction. What is the difference between the dissociation and the ionization? Well, we mentioned that. Let's answer these questions. A molecular compound that can be ionized. Oh, a molecular compound that can be ionized, we should look for the electrolyte. Strong acid, weak base. This is salt, no. This is ionic compound, yeah, it's strong acid. This is not electrolyte, it's not electrolyte. So the right answer is B. Which of the following presents in a molecular compound? In a molecular compound, we know that molecular compounds are two classes, polar and nonpolar. Only nonpolar covalent compounds? No. We have polar also. Only polar covalent compounds? No, we have nonpolar also. Polar and nonpolar? Yeah, that's the right answer. It's a wonderful question. What attraction force is greater than the attraction force between the molecules in? Okay? For example, we have HCl. We have the attraction between H and Cl. Okay? When we put HCl into the water, H2O, so it starts to form the attraction with the water. Okay? So, if the attraction force, if this attraction force between hydrogen and chlorine is stronger than the attraction force between water and chloride, it cannot be ionized. Look, this is HCl. HCl, this is Cl, and this is H. Or in another form, how we can explain it? Just like that. Okay, I'll bring this. It's very good. Okay, excuse me. It's chlorine and it's hydrogen. This is HCl. Okay, there's the attraction force between them. And this is water, it's water. So look, if the attraction force of water and the solute is greater than the attraction force between this and this, look, I can't separate it. It will be ionized. Why? Because of the attraction force between my hand and the solute is bigger than this attraction force. But what will happen if that attraction force is bigger than the attraction force of my hand? Look, I cannot split it into its individual ions. So this is the same phenomena that we have in here, okay? Look, it's just like that pen that I showed you. If this attraction force is bigger than that we have in here, so it will not be ionized. But if the water attraction force is bigger than the attraction force of the solid, so it's gonna be ionized. Now, water attraction force is greater than the attraction force between the molecules. It means it will be ionized, okay? All molecular compounds, no. Only for polar electrolyte. Molecular electrolyte compounds, yes. That's the right answer, immediately. That's the right answer. About the hydronium ions, the hydronium ions are mostly produced by dissolving acids in water. For example, HCl plus H2O to form H3O plus Cl negative. So how we get the hydronium ion? First of all, when we put HCl into water, it will be split to H plus and chlorine. But because of H plus is a very active ion, so it cannot stay freely, it cannot stay alone, so immediately it will react with a water molecule by a covalent bond with oxygen to form H3O, which is exothermic. So how we get hydronium ion? Firstly, when we put the acid into water, the H ions will be separated from the acid, and because of they are too active, they are super active, so they cannot stay freely alone. That's why they're gonna form a covalent bond with the oxygen of water to reform the bond and to form a hydronium ion, which is exothermic. So that's about the hydronium ion, and we have a rule of the hydronium ion. So the hydronium ion is produced by the acids and it's exothermic. Formation of H3O from the solution of HCl. Yeah, I accept it and it's exothermic. Accepted and endothermic? No. Right, it's accepted, but it's not endothermic, it's exothermic. Not accepted and exothermic. Yeah, it's exothermic, but it's no, it's accepted. Accepted and exothermic. Okay, this is the right answer. Which of the following represents a hydronium ion? A hydronium ion or hydrated proton? For now, we only get H3O. H plus, no, it's not hydronium ion. After reacting with water, it becomes a hydronium ion. H3O, yeah, it's hydronium ion. Hydrogen chloride molecule, no, it's HCl. HCl is an acid. Water, no. But when H plus water are combined together, they can form a hydronium ion. Now, how we can recognize the hydronium ion or the hydrated proton? Okay, how we can recognize the hydrated proton? For example, we have the following formulas. So, how we can decide that they are hydrated proton? Okay, we have a special rule. Look, I'm going to show you. Okay. Well, let's see how we can recognize a hydrated proton. Number of oxygen multiplied by 2 plus 1 plus 1. We should get the number of hydrogen. Okay? Look, how we can apply this equation. H3O, we have one oxygen. 1 times 2 plus 1 is equal to 3. Do we have 3 hydrogens? Yeah, so it's hydrated proton. H7O3, okay, number of oxygen, 3 times 2, 3 times 2 plus 1 is equal to 3 times 2 is equal to 6, plus 1 is 7. So, do we get 7 hydrogen atoms? Yeah, we have 7 hydrogen atoms. So, it's hydrated proton also. Okay? Hydrated proton also. About that one. About that one. H4O7. Okay? Number of oxygen, which is 2. 2 times 2 plus 1 is equal to 5. We have 4 hydrogen or 5 hydrogen. We have 4. No, it's not hydrated proton. In here, H9O4. Okay. Oxygen is 4. 4 times 2 is equal to 8 plus 1 is equal to 9. So it's hydrated proton also. So the only one is not a hydrated proton. Which of the following is not a hydrated proton? That one. The right answer is C. C is the right answer. This is not the hydrated proton. Which of the following has the maximum hydronium ion? Okay, let's answer this. The strong acid is weak acid. We cannot compare weak with the strong one. And this is base, no. This is weak also, no. So the right answer is A. A is a strong acid. About the electrolytes. Okay. So the last thing in the section 1 is the electrolytes. Let's talk about the electrolytes. Well, I will show you some examples about the electrolytes in here. We only need 5 minutes. Okay? We only need 5 minutes. Okay. About the strong and weak electrolytes. For strong electrolytes, for strong electrolytes and weak electrolytes. Strong electrolytes are electrolytes that can dissolve in water and they can conduct, their aqueous solution can conduct electricity very well because of there's a large number of the ions. Large number of the ions. But in here, their aqueous solution can conduct electricity poorly. Why? Because of small number of ions can be produced by this electrolyte. A strong electrolyte such as strong acid, strong base, okay? Strong acid, strong base, and highly soluble salt. Weak electrolyte, weak acid, weak base, and slightly soluble salt. For example, we have HCl. HCl plus H2O. We should write a single arrow for the strong electrolytes because the electrolytes going to ionize completely, okay, to form hydronium ion H3O plus and Cl negative. But for weak electrolyte, for example, HF plus H2O, we should write the double arrow, reversible arrow, to form H3O plus and F negative. Why? Because of a small number of that molecule will be ionized. So in here, the smallest concentration in here, this is 0 because of there's a weak attraction force because of there's a weak attraction force between hydrogen and chlorine, so it will dissociate, it will ionize completely. In here, this is the maximum concentration of the ions. Too much ions can be produced by that one. That's why it's strong electrolyte and can conduct electricity very well. But in here, because of the strong attraction force between hydrogen and fluorine, so the bond is too strong, only a trace number of the ions can be produced because of the bond is too strong. That's why the aqueous solution of weak electrolytes can conduct electricity poorly. The point is that the reaction arrow for strong electrolytes is single arrow and for weak electrolytes is double arrow, which is reversible arrow. تاوانێ داهاتوو بە خواتان دەسپێرم هەر شاد و سەرفراز بن خواتان لەگەڵ